Okay, let's just briefly review what we did today. So we released a 2.1 quiz, so corrections will be due on that at midnight tonight. So make sure you reference the Google Classroom post for correction guidelines that will help you correct your quiz. I've got some explanations in there, student responses that'll help you kind of help guide you through those corrections. So some things that went well on the quiz. Or percentile interpretations. That was a lot better. People were saying equal to or less than. And then the shifting data question was really good. So that was like shifting your data up and down. That turned out real well. So great job on that. That was the last free response question. And then interpreting z-scores. Z-scores basically went really well. A lot of people said below when they were interpreting, like you specified the directions. And then the only things we want to kind of look back on that were a little consistent was interpreting a percentile graph. So those cumulative relative frequency graphs, those were a little inconsistent, so just making sure we're reading those correctly. And then the Tiger Woods question about is he old or not, you really want to, when you discuss an idea, when you have percentiles, you always want to use the percentile to kind of justify if something is uncommon or not. So the Tiger Woods question is one you'll want to go back to on the correction guidelines and just make sure you understand. So you can retake quizzes. Or you can come to tutoring to do that or schedule a time with me about that. So we did some shout outs. Lillian got a shout out. Woo! All right, so here's what we were looking at today. We're doing density curves. So we're basically making a picture of data and then deciding what it looks like and what information we can get from it, specifically the mean and the median. So in today's motto is going to be a picture is worth 1,000 words. So in statistics, we always have to make sure we have a picture of our data and we can interpret said data. So we looked at a situation, a couple different things, and tried to decide what do we think the shape would look like. So the distribution of ages of people in the building. So if I made a graph out of the ages of people in this building at Wellspring, we said it would be a right skew just because you'd have a lot of teenagers, but then you've got a couple of teachers that are obviously older, so that would skew the data. The other thing we looked at is test scores for an easy test. So if a test is easy, that means a lot of people we can assume score high, but a few people may not. So that's going to be a left skew. If it was just a general standardized test, we did discuss that would look a bit more symmetric. So we collected some data for a few different experiments. So we rolled the dice. And then collected data from that. We made some predictions and we talked about the data being flat because in a perfect world, if it's a fair dice, you've got an equal chance of each number. And then basically our picture also showed that except for the 5, so it was a little funky. But in the long run, we said each number in a perfect situation should come up the same number of times. So this is a uniform distribution. Then we looked at a spinner. So we're spinning a spinner until we get a 2. So these were some of our predictions. Basically, we decided it would be skewed. So either you're going to get 2s right away and then have a few times where it takes forever, or opposite of that, we've got a situation where it takes forever and a few people got it really quick. Either way, these predictions are pretty good just because it's going to be skewed based on how long it takes to get that 2. Now, our data did show a right skew. So we kind of marked out, hey, the median is going to be here with everybody else, and the mean is going to get pulled up because there's a couple people that took forever to get that 2. So the median is less than the mean here. But in our predictions, just identifying that it would be skewed is fine, left or right. Either way, that logic is pretty sound. So then for experiment 3, we stopped a stopwatch at 5 seconds. And we predicted it's basically going to kind of be symmetric because most, we're all counting to 5. So then if we're all counting to 5, we should have most people close to 5. And then a few people may have stopped early or stopped late, creating kind of a symmetrical shape. So ours, for the most part, was symmetrical. We got a couple funky points here. But basically, again, for a symmetric curve, the mean and the median are both in the middle, since that's kind of where a lot of the data is. And the outliers, if there are any, kind of balance things out. But basically, we're going to have those be equal. So then we looked at this idea of a normal curve. So this is where we kind of came back together after collecting things and decided, okay, in statistics, there's a pattern that eventually emerges with data. And one of those very common patterns is what we call a normal distribution or a normal curve. So basically, we took our timing data, since that was nice and symmetrical-ish, and I converted it into kind of this picture of what's called a normal curve. So the two most important measurements for a normal curve are your mean and your standard deviation. So we typically mark out where the mean is, and then generally we won't have any more of the data falling outside of 3 standard deviations above and below. So this little symbol here is a symbol for standard deviation. And basically I'm marking out, 1 standard deviation up for a z-score. Remember, z-scores are how many standard deviations you are. So this would be a z-score of 1, a z-score of 2 and 3, basically meaning I'm adding the standard deviation each time to get to that point. And then noticing, obviously, the data gets flat. We don't have a whole lot out here because that's 3 standard deviations is pretty far out. Similarly, we went the other direction and subtracted. So then we kind of looked at our data and just we're looking for some patterns, because generally with a normal curve, some patterns do eventually emerge. And we can take a normal curve and pull information from it to kind of like examine the things. So we just kind of messed around with this picture and basically said, all right, we guesstimated. We said, what percent of the data is within 2 standard deviations? So I went back and looked about where 2 standard deviations is and kind of marked that out roughly. There was a green line here, my bad. We marked out here basically where 2 standard deviations would be, and then estimated about how much of the data was there. And we said it's almost all of it. So we went with a 90% estimate. Then it says what percent of the data is further than 2 standard deviations from the mean. So that was basically these guys. But we said, hey, if 90% is between it, there's 100% of the data there. So if we just take 100 minus 90, that's going to tell us what's not in between, which is 10%. So we estimated this to be about 10% left over of the data. And then this yellow marking is this question here. So what percent of the data is greater than 1 standard deviation above the mean? So we marked out about where 1 standard deviation above was. So I went back here and looked. So I marked that out, and basically if we had to estimate about how much was greater than that, we set it at about 25%. Like if I cut this in half or cut this into 4 pieces, we're going to have maybe about a quarter of the data-ish within here to do that. So that was kind of all we've done today, was just kind of get a picture, talk about the shape, why does it have that shape, and then what information can we kind of pull off of that picture to tell us where some of our data is and like how much of our data. So important ideas and check for understanding we're going to do together tomorrow to make sure we are good on this. This section tends to get a little tricky, so if you do have questions on it, please ask right away if something is confusing, because we don't want anyone to get lost. So that's it for today. Thanks for joining or rewatching this recording if you didn't understand things.